Okay. So just very quickly, remember last time we had the headers, and we were talking about creating getters and setters. Getters and setters, there was a little bit of confusion last time, that's fine, it's the first time you're seeing it for a lot of you. They're not really even that special of a function. They're just a function where its only purpose in life is to either get something or set something, like some of those private attributes. That's all it is. It's not that, oh, C++ have a special keyword. Like, how does C++ know it's a getter? It doesn't. It just knows it's a function, and if and when the programmer calls it, it's just going to do what the function does, which for our getters and setters will just be getting and setting values. So we saw them here quickly. Here's the getter and a setter for first name, last name, student number. We should never be able to change it, so maybe all we can do is set it. Email address, just get it, shouldn't be able to change it, it's set once you get here. And the average, we can get it, and perhaps we can add some extra data integrity check with our setter, where if someone tries to set the value of the student's average, and it's not between 0 and 100, it just won't let you. It'll just say, like, it just won't work, it won't do it. So this helps to enforce that the data is kind of consistent the way it's supposed to be. So if we go over here, here's the program we were running last time. So this is a very simple one. Of course, last time we played around with this. Who here can tell me why this won't work?
It's private.
It's private, exactly. That's all it is. I set that attribute to private. If it was public, I could access it, but I set it to private, which means that I'm not allowed to access it from outside that class. It's against the rules. Again, you might be asking, just make everything public. Doesn't it make your life easier? I suppose in some sense it makes life easier, but also this public and private thing is given to you as a tool to kind of help design your program and your code in a way where if I don't need to access it outside the class, I shouldn't, because it just simplifies everything. It gives you more control. So don't make everything public, that's bad. And if we go look at our header, I added the getters and the setter functions to the public section of the header. Why are they public? Well, in order for these functions to be of any use, they need to be publicly accessible, because these are the functions that are designed to be used in another class. Like if I'm in the main function, I can say, hey, student, give me these private attribute or something, right? So they're public because we want to be able to access these functions publicly. And in here, I wrote, so we've got our constructor, our deconstructor, and I wrote all the getters and setters in here, literally copy and pasted them from the slides. That's all. That's all we've seen so far. So let's quickly test it out. I'm going to go back to my main. So I can't just access last name like this, but I can access it if I call the public function getLastName. GetLastName, of course, it's a function, it's a method. Let's test it out. It's taking forever. I wonder if there's a power setting I can change on my laptop to make it a little beefier. Oh, it's running for best performance. All right, whatever. Anyways, all right, we built it. Now if I go over here and I run it, we will see it comes up with dough. And that's exactly what we expected. Right? What's its last name? Oh, well, it's dough. We accessed it with the getter. So what happens? Oops. Let's change this to get first name. First name. Then down here, here's what I'm going to do. I'm going to say ys dot set. Or I guess it needs to be the arrow. What should we set the first name to? Someone yell out a name. Right now it's like John, right? Pardon?
Sarah.
Sarah. With an H?
Yeah, the right way.
All right, the right way. Okay. And then I'm going to go here, copy. copy this over and print it back out. Build it. Take a second, think, what would you expect to see printed out here? Take a second, think about it. Well, don't yell it out. How many print statements are there? Well, print statement. How many times am I printing something out? 2. The first time, what is the first name of the student? John. Then what did I do to it? Changed it to Sarah. Then I print it out again. What should their first name be? Sarah. Let's make sure we're not crazy. John, Sarah. That's it. Getters, setters. You might think this seems silly. Well, stick with it. It'll come together in the end. Any questions about any of this now so far? Okay. So we go back here. Yeah, getters, setters. And now if I test it out, in this particular scenario, what would you expect to see? Oh, before, let's have a real quick test. Is the student object being created, is it in dynamic memory? Yes? No? What do you think? Yes? No, absolutely not. Whenever you see new, think dynamic. So we've created a student object, and we get its first name. What should their first name be? First, on that first print. John. Then we change it to Bob, and then what should be printed out the second time? This student object. Dynamic memory? Yeah. So this one. Don't worry, I threw it at you. It's a test. How many student objects are being created? 1. How many student variables are there? I don't really have one actually, right? Exactly. It's like a different type. I tried to trick you. It's a student pointer variable that gets us to that student. And then, so of course, because I have a pointer, I have to use a little arrow thing instead of the dot. So the first time I print out, see how I'm doing like the bracket star, what am I, close bracket dot, versus what am I, arrow? See that? They mean basically the same thing. The arrow kind of does the dereferencing for you with the dot, basically. Where if you put the star in front, it means dereference and then the dot. Whatever. Yes?
So what would you prefer us to use during assignments?
Whatever you want. A lot of people, as long as you find one and stick with one that you like, I would very much recommend the second one.
Okay.
It's a little cleaner, let's say, right? People will argue about what's the better way to do it. C++ has a lot of conventions that aren't consistent. As long as you pick one and you're consistent, I'm happy, but if you had to pick, I'd recommend the second one. Cool. And of course, because it's dynamic, I have to delete it. Great. First time it's printed out, what's their first name?
John.
Second time? Sally. Great. So there you go. See the difference? Like I talked about a moment ago. So recap so far. What have we done? We've defined the object. We've defined like the class. We're saying this is what it means to be a student. And I've only created one instance though. And okay, in creating it I needed the header and the setter, but I only created a single instance of a student object. There was only ever one student object in existence so far. Every time I hit run, there was only one in existence in the computer. And we were interacting with that instance. I created it and I changed its name and whatnot. Very simple stuff so far. It's going to get a lot more complex, don't get me wrong. But that's all we've done so far. Not too bad. Very simple objects, just storing some information for us. So let's create 2 instances. If I do something like this, and I hit run, what would you expect to be written out, printed out? That's not a trick question.
John and something else, whatever your second instance was.
Well, in the constructor, okay, so you brought up one important thing. How many student instances exist right now? Two, right? And their name is student A, or pardon me, A student and B student. When I create an instance, what's their name going to be by default?
John.
So how many instances did I create? Both of those instances, their first name will be John. It's got the default value. Okay, how many instances? Okay, whatever. So that's basically what I was just asking you right there. So we created two instances of a student object that all had the same values at the start. It's kind of silly, right? Because of course, what I could do is create an instance and set their name to Sarah, then to Bob, and then to Sally. For every instance. If I create 3 instances, I could change them all as I need. But what we're typically going to want to do is kind of cut out the middleman there and simplify these things. What we're going to do is we're going to create what we call just another constructor. It's going to be like an overloaded function. A not default constructor. And we can have as many of these as we want. So here's what I'm going to do. I'm going to write a version of the constructor that's basically the same as the first one, but where the first one just assigns some default values like John Doe 0000 J Doe at StFX.ca, where those were all set by default. Why not just have a constructor that takes a bunch of parameters and then I'll assign those as we go. Like, so when I call the constructor, I can specify the values that I want to be in there. To cut out the need to create it with the default values, then to change it, why not just create it with the values you want? So that's this right here. This line, see? This is under the public part of the header. I've added this. So this constructor is going to take a string, first name, last name, a student number, an email, and their average. That's it. So I'm going to, let's go back here. In fact, I'm going to be lazy and copy this. No way I want to type that all out. It's a long one. You can't see that I'm copying it, but I am. I'm going to go back to my header. And typically I'm going to want to put this there, next to the other constructor. So I put it in the header. So C++ is like, okay, so this is going to exist. Now I just have to go write it. So, oops, let's go back to here. This is how I would write it inside my class file. I'm just going to do the same thing. I'm just going to take this code, paste it directly into my C++ code. So let's go here. Typically, we like to keep them next to the constructors kind of together. There. Everything's fine. Take a second, look at that. Does that make sense? All it's doing, remember, the constructor, it's just a function. It's just a method. And it takes, I think it was like the 5 parameters. It's going to say, okay, what first name, last name, and whatnot. And it's going to take the first name parameter and assign it to the class attribute, first name. It's going to take the last name parameter, lname, and apply it to the last name class attribute, last name. Again, those of you coming from Python, I don't need self in front of here. But I could very well put this, if you like having that convention there, where this means a pointer to this object. You don't need it in this situation. But that's it. That's just it. But now this gives me the ability to go back here to say, okay, well here, I'm going to give it Sarah Smith, student number 0, their email, StFX.ca, and their average is 99. They're doing pretty well. 0.9. Great. I'm going to build it. But now, what would you expect to be printed out when I run it? Oh, what do I have an issue? Debug. Cannot open. Oh, that usually just means I need to rebuild it. For some reason, something goes funny. So what would you expect to be printed out? Why? Why Sarah? Because that's the first name I just set it to. So let's run it. Sarah. What if I said my S set first name to Bob, and then I printed out what was previously known as Sarah's. Sarah, the first name was Sarah. What would you expect to be printed out? Bob. It's basically the same thing as before, but now instead of assigning it with the default values, I could put it whatever I want. I can have as many of these constructors as I want, as long as they all have just different parameter lists, different sets of parameters. And then C++ will call whatever one whenever you call it. If you call it with like 2 strings and an int, it's going to go look for the function that has 2 strings and an int with that name. If it can find it, it's happy. If it can't, well, you'll have a problem. But that's nothing new. So I could create a constructor where maybe I'll give it a first and last name and an email address, and somehow it magically generates a student number and sets their average to some default value. So we can have any combination of half default, half setting constructors we want. This one will be good enough for our purposes right here. But this is it. Simple. Any questions about this second constructor? Yeah?
Kind of like unrelated, but when you went my S and then like the dash and arrow get first name, is there any difference between that and like using just a dot?
Yes, because the dot will only work if my S is the object. But of course, what is my S? It's a pointer to the object. It's a pointer to the instance.
Yeah.
So the arrow means basically dereference then dot.
Oh.
It's literally, here, I'll go back here because I had it in the slides. See, right here, what star, what am I versus the arrow?
Okay.
Basically the exact same thing. Yeah?
So then, what if you were using the object instead of a pointer and you still use the dash arrow? Would that still work as well?
No, it won't work because it'll be like, this is the object. It's kind of like you're trying to dereference something that's not a pointer. Yeah?
So if you're going to make 2 students, you'd need 2 different constructors, or could you use the one single constructor?
Oh, you can use. Great question. Let's do it right now. Sarah and Vera. Great, except this one will be called MyS1 and MyS2. So I'm calling the exact same constructor, but I'm passing it 2 different sets of parameters. The only difference is one is Sarah and one is Vera. What's wrong? What? No, it's all right there. Oh, oh, here's why. MyS1. Of course, now I must also delete MyS2. So I'm calling the same constructor, the same bits of code, but it's going to still create the 2 separate things. I can make a billion instances with the exact same constructor, all having different combinations of values. So let's run it. Sarah and Vera. There. I assume that's how you would pronounce that. I don't know. But Vera, that's how you pronounce it? Yeah. We got it officially. Yeah.
I just remember in Python, like we had a repr. Is there anything like that equivalent
There
in
would-
C++?
Yes, kind of. We'll get there. Give me a minute. It's coming up pretty soon.
Okay.
So yeah, so the second constructor, great. So now if I have Bob's, I literally just showed you this, except the way I did it a moment ago was with 2 students created in dynamic memory. Now I'm creating 2 students that are just going to hang out in static memory. I'm creating one with Bob Smith, whatever, and now we have Sally McLeod. So, and we've got A student and B student here, and I'm printing out their first names and first names. So of course we would expect to see what printed out first, followed by what? Good job. Yes, of course. How many instances of the student class are there? 2. But how many ultimate definitions of the class? Just 1. I defined what it means to be a student once, and now I created 2 instances. Is there anything stopping me from creating 3? How about 17? How about 704? Exactly. I can just keep going forever. I can create a for loop that goes to 1 billion and just keep creating new ones. Why? Because. So create 2 instances, print them out, and this is closer to what I showed you a moment ago. We've got, I created them in dynamic memory. And again, I know I said this last time, but I'll emphasize it again. A lot of times throughout this course, I'm going to deliberately be using this strategy with the pointers and dynamic RAM. Yeah?
Maybe I just missed this, but is there anywhere where like we define how much RAM is dedicated to the static memory? Is just...
Oh, the computer, when you hit build, it's going, like when you hit build and you go to run it, the computer's going to know how much RAM it needs to set aside for the static memory thing. And it's also going to know how much RAM it will ultimately need to set aside for the dynamic memory stuff based on how the class is defined. So if it comes along and says, oh, they're going to create a student object somewhere, because I know that the student object has these methods and it's got these attributes, I know how much room I need in there for that. But asterisk, because when we're about to see where kind of knowing this stuff beforehand gets a little hairy. Hang in there. Your head's in the right place because you're asking all these questions that are like a couple slides down from us. So good. Anything? Yes?
So when you're making like a second constructor, it can be the same name, I guess the other constructor, like they can share the same.
Yeah. And same with any functions. You can overload functions. You can have 2 add functions. One that takes 2 integers and one that takes 2 boolean or 2 floats, doubles. They're literally identical. They both take 2 parameters, but the types of the first are integers and the types of the second are doubles. And as far as C++ is concerned, those are 2 separate functions. Same thing goes with constructors. You can have 1 billion of them with the exact same name as long as the parameter lists are different. Parameter lists being which parameters they take and their types and whatnot.
Because I'm only seeing the one when I type both of the same student.
Oh, maybe you need to save, rebuild, or something just to make Xcode happy or something.
Okay.
Any other questions? Okay. So more functionality. So far we've only come across accessors, mutators, and, or pardon me, accessors / mutators as methods for our class. It's pretty boring so far, so let's add a little bit more functionality. These 2. This comes to what you were asking about literally 2 minutes ago. So the first thing we're going to do is create a special function called toString. This would be similar to the repr one, kind of. And we're also going to create an equals method. toString is a very common method that you would write for whatever, like for your classes, that basically means, okay, you've got a student object. It might be handy, like if you as the programmer, it might be handy at some point in time to kind of like get some sort of string representation of what that object is, right? So if I want to like take a student object and I want to convert it to a string, maybe that means give me their first and last name and student number or something. I don't know, whatever I want. Remember, I'm inventing this stuff. But I'm going to want to have a function method that returns a string version of the object. I'll show you an example of this in a moment. Hopefully that'll help it make sense why we would want to do it. And another thing that I'm going to want to write is an equals method. What does it mean for two objects to be equal? I'm going to define this. I'm going to say, maybe if two students have the exact same height and hair length, then they're going to be equal. That's a pretty silly example, but I could do that, presumably if they had those attributes. A more reasonable one in this particular situation would be if they have the same student number, then those are probably equal students. Because sometimes, imagine I have two instances of an object. There are two instances, but they actually represent the same student. That could happen, right? There's nothing stopping me from making a James Hughes student number 7 and another instance of James Hughes student number 7. And I might want to ask, are these the same? Are they the same? Maybe that's handy. One thing very important to note here about C++ compared to Python or other big programming languages like Java and C# and whatnot. Remember how in Python, if you called like repr, it kind of gave you a repr for free, right? If you didn't write it, it gave it to you for free. Who here remembers what that was? What did it do?
It did like, if they were the same memory location?
No, that was the equals.
Oh, is that what you're talking about?
I'm asking about the repr. Okay, let's do the equals one. The default equals in Python was, like if you didn't write an equals method, Python gave your class one for free. And the one it gave you for free was, oh, are these two objects literally in the exact same memory location? Imagine I had two pointers pointed to the exact same object. If that's the case, they're going to be equal. It's a reasonable thing to be by default. But of course, we might want more functionality. We might want to be able to ask grander questions like, hey, do they have the same student numbers? But by default, it gave you one. And if we wanted to have our own, we would override the one it gave us for free. It would basically be like, okay, if I write my own, ignore the default one and use the one I've written. Because I want you to treat this as how it means for two of these objects to be equal. Similarly with the toString, Python gave you one for free, and it would just tell you like the class name and memory address where the instance is held. Not particularly useful, but it gives you something. So you, as a good programmer, you would write your repr that would give you an actual better view of what the heck a student object is, or whatever object you wrote, and it would return the string representation that you defined for that instance. A little bit more information than just where that instance happened to exist in memory. But the big thing here in Python is it gave you these functions for free whether or not you wanted them. If you wanted to overwrite them, you could. If not, you didn't have to. Whatever. You should have, probably, but you didn't have to. Java, they would give that to you for free as well. C#, they give it to you for free. C++, no. C++, if you don't write it, it doesn't give you a default one. But there's actually some benefit, which we will see as we go down and learn a little bit more about inheritance and whatnot in the course. There's a big, huge benefit to having these things by default. The crux of it is, by all objects you ever write, by all classes you ever write, you're guaranteed that that class will have a repr, or that class will have a toString, or that class will have an equals. You guarantee by all of them getting it by default, whether you write it or not, you know that all classes will have it. That ends up being really handy. But we're going to hit this more later about, like, we can't do that with C++ because we can't guarantee that it exists. And some of the perhaps frustrating little things that come up because of that as a consequence. But anyways, we're going to write our toString and our equals. So toString, that's like a special function that will simply return a string version of our object. And note, it is whatever we want it to be. We're inventing it. Do we want our toString to just return the string hi? So any instance of an object, any instance of a student object, if I say hey toString, it just gives me back the string hi? Is that a particularly useful toString? No, I mean, no, it's not. So we're going to write our own. We'll start by adding this to the header. And we'll add something like this to the class. Have a look at this code. See if you can make sense of what it's doing. Give yourself 20 seconds. Don't yell out the answer. Just see if you can make sense of it. Maybe talk amongst yourselves. See if you can kind of deduce it together. Oh my goodness. Yeah,
I had a question actually.
what's up?
What was the /T again?
That means tab. That means like just add a tab. Yeah. Who here has an idea? Raise your hand. Quick poll. Yeah. So who wants to tell me? So you're iffy. Let's see if we can see if you were right or not.
I didn't work out all the exact formatting, but it looks like it's just adding like variables and spaces as needed, so it'll print something along the lines of like, here's the first name, here's the like.
Yeah. So what we're doing first is we're building a string. We start with a string variable s, take the first name, append to it a space, and then the last name. And then again, take that s and append to that a space, open parentheses, get the student number, plus close parentheses a space, and then we append to that the email address plus a tab, like you asked, and then the current average. Now, yeah, you got a question?
Can you not do plus equals with strings?
Yes, you absolutely can. I'm pretty sure you can in C++. Check it for me. I know you can in Python. Have a quick test. Let me know. Now, you might also notice that I'm calling a function called toString within my method called toString. I want to be very clear about something. I am writing, this might be a little confusing, but it does make perfect sense. Bear with me. I'm writing the method toString. The toString method I'm writing belongs to which class? The student class, right? So I would take a student object and be like, okay, hey, you, what's your string value? And then I would ask another student object, what's your string value? And then another student object, what's your string value? And they're going to give it all these different things. So where is this toString method written? In the student class. I'm calling a completely different toString method though. I'm calling the toString method from the standard library. And this one works a little bit differently, actually. This will take like numbers and convert them to strings. Because you know in Python, if I just added like a number to the string, sometimes it was happy and it would just like convert it to a string for you, whatever, it was good. C++, remember, you have to be very careful with your types and whatnot, so you can't add the string and a number together. You have to convert that number to a string before you can add it to a string. Long story short, making sure all the types check out so I can add the strings together. And the toString that I'm calling to convert the number to a string is a very different toString than the one I'm writing for the student class. Later, we'll be writing a toString method for a bigger class too. Shortly, we'll be doing that. And you'll kind of see these cool layers of toStrings. Another thing to note too as well, what am I doing with the string? Does this function method ever print out the string? No. Everybody else know? No. What is it doing with the string? Returning it. Good. That is often one of the mistakes people make when they're first starting out, is their toStrings aren't returning the string, it's printing out the string. No, that's not what we want. This method, all it does is creates a string and gives it back. Then whoever gets that string can do whatever they want with it. Maybe they want to print it out. Maybe they want to do something else. I don't know. So I'm going to go add this to my code. We go back here. Let's go back to my header. Oh. There's that. And then, of course, give me one moment while I copy my code. There. There we go. So now I have added that toString function. So if I go back to here, so instead of doing this, here's what I'm going to do. The string of student equals my S1 toString. There. So now, and you know what? And for the fun of it, we'll just repeat this code right below and just override it with my S2's toString. So now I'm asking each instance what their string versions are. I'm getting it back, and then I'm just printing it out. Based on the values I gave it, I've got Sarah Smith. Their student number is 0. S. Smith at StFX.ca. And their average is 99.9. And then, of course, the second instance that I created, which is basically identical to the first, with the change of Sarah to Bara. And now we have Bara Smith, and what else? There, done. So both instances, when I asked an instance, give me your string thing, give me your string value, it was the string value associated with that particular instance. If I had a third one, it would give me a different string value based on that third one. So that's the toString. Any questions about that? So the toString is just, it's really handy, and often for debugging, you're really going to like it. You include this so when you're writing code and your stuff's not working, is that really the object you thought it was? Maybe if I print it out, oh my, it's not what I thought it was. It's great to let you know if everything's going right or whatnot. So there we go, toString test. Great, just like that. I just showed you. Yes?
Was that like the proper convention on like how to call your toString? Pretty much like setting it equal to another.
You can set it equal, or you could call it right in the print function because it returns the string, which you can immediately print out.
Okay.
You can use it however you want.
Okay.
All you need to know is that it returns a string. Do whatever you want with that.
Okay.
Like, have a look here. See the difference? See how I didn't actually assign it to a string variable? I just
Yeah.
immediately called it in the output. That's all.
Okay.
Yeah. So equals. We might want to know if two students are equal. What does that mean in our situation? Whatever we want. We're defining it. We invented the student object. What does it mean for two students to be equal? So we get to define it. So we would add this to the header. And here's a good example, I think. If the student numbers are the same, return true. Otherwise, return false. Who here remembers from 161 why I hate the way this code is written? Just curious if anyone remembers. In practice, I wouldn't write it this way. But just one sec, I'll test if you're right. But I'm doing it this way to make things really obvious. What don't I like about this?
If it's true, then return true.
That's exactly it. Let me ask the question for a second. Let's say student number equals other student number. Okay, first let me be clear about something. What am I passing to this equals function?
Two student numbers?
No, I'm only ever passing it a reference to a different student. That's what the ampersand means, which we're going to not use in a lot of cases in this class deliberately. But basically what it is, it's a different student object. So it's like you asking me, hey, are you equal to that student over there? So I'm like, okay, well, what's my student number? Hey, what's your student number? And I'm going to check them. You in that case would be other. So I have student number equals other student number. If the student numbers are the same, probably the same student. Seems reasonable. So why I hate this. If my student number, I ask the question, does my student number equal that other person's student number? Let's say it's true. So if the result of my student number equals other student number, what does that give me? True. And then what do I do if it's true?
Return true.
Return true. So if it's true, return true. Okay. But what if my student number is not your student number? What does that equals return? False. So if it's false, what do I return? False. So if it's true, all we're doing is returning true. If it's false, all we're doing is returning false. Why not write return student number equals other get student number? Why not write that? Because if the answer to that question is true, it just returns true. If it's false, it returns false. Literally the exact same thing. This code right here, the way I've written it, it's almost like a meme in computer science about like, oh, ha ha, this is so silly. Why would you ever write it this way? I mean, one argument to write it this way is it's pretty verbose. In a good way, maybe. Like, you look at this code, you immediately know what it's doing. But it's kind of like a joke in computer science to write this code this way. So, why did we make it a reference? Well, if I passed it, if I didn't make it a reference, if I gave it another student object, C++ would make a copy of the contents of that variable. And we would create a copy of the student object to compare. Is that necessary? If I want to see, hey, are you equal to me? It seems like it might be a bunch of extra work to be like, okay, hey, you, let's make a copy of you and then see if we're the same. Why make a copy? Why not just go, like, hey, reference that one and then get the information? Kind of makes a little bit more sense, right? So we could do it with a pointer too. But of course, in this case, we would need to say, okay, other get student number. Then if I were to call this, here's how I would do it. So I have A student, B student, and C student. Actually, do I have an example with the pointers? I do not. Okay. I have A student, B student, and C student. There are 3 different instances. How many instances of student objects do I have? 3. And I ask, hey, A student, are you equal to B student? And based on our rules of being equivalent students, that's only true if the student numbers are equal. So effectively the question is 1, 2, 3, 4, 5, 6, 7, 8, 9 equal to 9, 8, 7, 6, 5, 4, 3, 2, 1? No, so should A student dot equals B student, should that be true or false? False. So it should give me false. It'll print out 0, right? Now what if I ask, hey, A student, do you equal C student? It's true. Why? Well, because their student numbers are the same. And we would do something like this if we were using the pointer version instead of the ampersands. We would have to dereference, or no, pardon me, we would have to get the memory address to be able to pass the pointer to the equals. So there's an equals. But no, it's like you're asking a specific one. That's like the A student dot. Or if you're doing it with dynamic memory, you would say A student little arrow. You're saying, hey, are you equal to that one? You're asking a specific instance if you're equal to whatever you're passing to it as a parameter. That's the idea for the equals. Any questions about that equals stuff? What time we got? I got a perfect amount of time to test you with this question. What is the answer? No knee-jerk reactions. What is the answer? Slow down and think, what does C++ do? Don't think Python, think C++. I'm going to give you a big hint, and this might tell you if you were right or wrong. Whenever we see an equals, we're making a copy of what's over here and putting it in over there. So when I hit run, I've got this, right? I've got A student, and what's an A student? Well, that's student object. And then I said B student is equal to A student. That makes a copy of it. So then when I say, hey, B student, set your first name to ABC, I modified B student. But did this affect A student? No. What about this one? How many student instances are there? One. And what am I copying over on that second line of code? I'm copying over the contents of the variable, but the contents of the variable is not a student object, it's a pointer. So I create another pointer pointing to the exact same object. So this is what happens. Whoop, changed it. What about this one? Last one real quick. It's a reference. You might remember it's this. The reference is literally just giving the variable like another name. So it's like you're accessing the exact same thing with the same name, or a different name. Cool. Cool. We'll pick up here tomorrow.